students, let's continue with our classification of transport layer solutions for ad hoc wireless networks. So far we discussed about the TCP, ELNF and TCP-F. Now let's see the another protocol that is a transport layer solution for ad hoc wireless network is the TCP BUS. So now let's see what does this TCP BUS will do. The TCP with BUS means buffering capability and sequence information. Buffering capability, BU means buffering and buffering capability and sequence information. So it is similar to TCP-F and TCP-ELNF. So TCP-F is a feedback approach, ELNF is a explicit link failure notification. So it is similar to these two protocols. This bus is similar to these two protocols in its use of feedback information from an intermediate node on detection of a path break, but it is more dependent on the routing protocols. So here also buses also depends on the intermediate nodes. So ELFN is also depends on intermediate nodes, but this TCP bus is more dependent on routing protocols. Let's see. The TCP bus was proposed with associative based routing ABR, associative based routing protocol as a routing scheme. So I said this bus is more dependent on the routing protocol. So what type of routing protocol it will be proposed? It will use associative based routing protocol as a routing scheme. Hence, it makes use of some special messages such as LQ, reply for finding partial paths. So this ABR, associative bus based associativity based routing use the special messages like LQ and reply for finding the partial paths. So just remember that TCP bus, that is a TCP with buffering capability and sequence information, uses a routing scheme like associative based routing, associativity based routing ABR. So this ABR uses a special messages like LQ and reply for finding partial paths. Okay, so now let's see the operation of this TCP bus. Now let's see the operation. Upon detection of a path break, so everything, whatever the protocol you are taking, whatever that TCP over ad hoc wireless networks you are taking, everything is whenever the path breaks, what it going to be do. So that the TCP, the transport layer solutions for ad hoc wireless network can be improved. So now let's see this operation of TCP bus. Upon detection of a path break, an upstream intermediate nodes called pivot nodes. So here are some upstream intermediate nodes and the downstream intermediate nodes are there. So upstream intermediate nodes, you call it as a pivot node. Let us take here the intermediate node as a pivot node. Originate an explicit route disconnection notification. So this pivot node, what it is going to do, it originates an explicit route disconnection, ERDN. Explicit route detection notification. ELFN is an explicit link failure notification. That is about the link failure notification. And here it is going to detect the route, explicit route detection notification message to the TCP bus sender. So here the TCP, so many nodes will be present. So sender and the receiver will be there. In between that some pivot node will be there. This pivot node originates an explicit route disconnection notification. Whenever the route is disconnected, it originates to the sender by sending a message like ERDN. Explicit route disconnection notification message to the TCP bus sender. ERDN, explicit route detection notification propagated in a reliable way. Upon receiving the ERDN packets, then what the sender will do? So whenever the sender receives the ERDN packet, the TCP bus sender stops transmission and freezes all timers and windows as in the case of the feedback. So in the just like a feedback, in the feedback or TCP also, whenever the notification is route break notification is received by the sender, it going to stop all the operations. It enter into the freeze state. In the same way, whenever this TCP bus sender receives the ERDN packet, explicit route disconnection notification is received, then it stops transmission and freezes. the packet in transmit at the intermediate node from the TCP bus sender to the pivot node or buffered until a new partial path from the pivot node to the TCP bus receiver is obtained. So here what it is going to do, what the pivot node is going to do, the packet in transmit at the intermediate node, so this is a pivot node, is the intermediate node, from the TCP bus sender to the PN or buffered, here it is going to be buffered until a new partial path from the PN. So until a new path is formed from the PN to the TCP receiver is obtained by the PN. So a buffer is maintained until a new path is established. So upon detection of a path break, the downstreams node is originated a route notification. So here we are talking about upstreams and the downstreams. So upon detection of a path break, the downstream nodes is originated a route notification RN packet to the TCP bus receiver, which is forwarded by all the downstream nodes in the path. So whenever the pivot node is going to be sends the ERDN packet to the sender is going to be freeze. So up to that you're clear. Now upon detection, the path break of the downstream nodes is originated a route notification. Why it is originated route notification? Because the path is broken. So we have to find the new path. New path can be found by checking all other paths. So route notification packet to the TCP bus receiver, which is forwarded by all the downstream nodes in the path. The pivot node attempts to find new partial path to the TCP bus receiver, and the availability of such partial path to the destination is intimated to the TCP bus sender through an explicit route successful notification. So whenever the correct path is found by the pivot node or all the downstream nodes in the path, it sends a explicit route successful notification. Previously explicit route disconnection notification, and whenever we find the correct route, all the nodes, the TCP bus sender through an explicit route successful notification packet will be sent. So TCP utilizes route reconfiguration mechanism of ABR to obtain the partial path to the destination. So that is the operation here. Okay, it's a very simple. So let me take the example to explain this. So upon successful LQ reply process to obtain a new route to the TCP bus receiver, the pivot node informs to the TCP bus sender of the new partial path by ERSN successful packet. The TCP bus sender also periodically originate probe packets to check the availability of the path to the destination. So that is a operation. So here you can see so many nodes are there. Some are the downstreams and the upstreams. So these are all upstreams and these are all downstreams. So here this is a source, and let us take 15 is the destination. Okay. So here I want to go from here. These are all the dotted lines here, the network links, and this is a broken link. And whenever the correct path is found, TCP data flow will be obtained, and ERDN. So these are the ERDN packets, means explicit route detection node. Okay, and the RN, LQ, reply, new partial and pivot nodes are there. So just first it sends the packet. Whenever this is the pivot node, 4 is the pivot node. So at the pivot node, this is the intermediate node, a route is breaking. So whenever it breaks a broken link is observed, it sends a back with ERDN message to the source node. Then what the source node will do? Source node will freezes. It won't transmit the remaining packets. It will enter into the freeze state until it sees the ERSN packet. Okay, so then meantime what it will do, all the remaining nodes, the downstream nodes are checked for the availability of the path. So checking all the availability paths. So after finding the availability path, it again retransmits the it sends a message ERSN packet to the sender, successful node. Okay, a successful node retransmission packet will be sent to the sender. Then the sender will send the data. So this is how the operation will be established. Now let's see the advantages and disadvantages in this routing protocol. So advantages is in TCP buses, performance is improvement, avoidance of fast retransmission due to the use of buffering, sequencing number, and selective acknowledgement. So here avoidance of fast retransmission can be done with the help of buffering capability. Sequence numbering is given and selective acknowledgements will be sent to the sender as well as to the receiver. Also takes advantages of underlining routing protocols. And coming to the disadvantages, increased dependency on routing protocols and buffering and intermediate nodes. So this TCP bus is depend completely on routing protocols and buffering intermediate nodes. Suppose if the intermediate node is failure, that buffer the packet may lead to loss of packet and the performance will be degradation. Thank you.